Hello everybody, this is Skadamus. This is part 2 of the video. It took me like 20 minutes to create another sphere. Well, it's the same sphere, but to remove the rubber ball and to glue these zinc pellets onto the sphere and to have the mass be almost exactly the same, slightly smaller. So we're going to use this zinc sphere now for the zinc trials. And I've already set up the Excel file for this. Here, and I put the previous trials which were on the whiteboard, I put them on the computer. So let's get the zinc trials started. So these are very unique zinc trials. The zinc is glued onto the ground. So this is a very careful version of the experiment. So let's get started. So zinc is predicted to fall faster. So let's see what happens. 6020, 6020. To keep in mind that there's quite a bit of glue mass in the mix. Well, not too much probably, but maybe 10% or something like that. Yeah, that could be it. Yeah, but we should still observe quite a bit of a difference in acceleration. I'm going to do 10 trials. $6.19. When we are done with this experiment, when I'm done with this experiment, I should check how many percent glue and how many percent zinc this is. $6.19. Yeah, it's faster, right? But not by much. At least not so far. $6.19. Of course, it could also be that it matters if it's a solid sphere or a hollow sphere. Okay, 6.18. It's better. Beyond the question of if the mass inside is jumping up or not. We should also consider a robotic release mechanism. 6.18 again, okay. 6.18. Okay, 3 more trials. 619. Okay, consistently faster, but the difference should be more. Could be due to the fact that we have only rather small amount of zinc here. Oh, this one is a large one. 621. This is an outlier. Let's try again. I mean, if it's very far away from the others, then it's okay to measure again. $6.20. Okay, we have a difference of exactly 0.1 milliseconds. Yes. Well, if we treat that now as an outlier, I'll measure once again. But well, it won't change the result that much anyway. Yeah, now that's an outlier again. Okay, so yeah, the difference is, as you can see, it's 0.1 milligrams, so 0.1 milliseconds. And okay, almost non-overlapping, but they're overlapping. Yeah, let's weigh one of these spheres to see how much mass they contribute, and we estimate how much the rubber contributes. The glue. So this is like 2.3 grams, and then you add all the glue, probably 5 grams. So 5 out of 15 grams, that reduces the gravity quite a bit. So and it could be that the mass distribution does matter. So we see in all trials that the materials that are predicted to be faster are indeed faster, but when you use exactly the same spheres with exactly the same rubbers, then this difference is reduced by quite a bit. And so, yeah, so if it really depends on the distribution of the mass as well, which would be hard to understand. I mean, it's understandable for a slope. When you have a slope, the hollow sphere will have more momentum. The mass has more momentum because it's all outside and it's rolling, so it has to traverse a longer distance. But in air, that shouldn't matter. Okay, well, the only way to further improve the experiment would be to do it in a vacuum, and we're certainly gonna try that at one point. Another way is to just try higher freefall heights. Yeah, and certainly the sphere should be more full. If they're almost empty like just now, then that might not be so good. There's not much pushing down, and there's all this glue. Best thing is, of course, to have, for example, lead spheres with boreholes in them. I did that in the beginning when I was using the clamp release mechanism. And this was the clamp that I used. Yeah, those are all still up on YouTube. You can check out those older experiments where there was no vending machine ball, and yeah, those were different types of experiments. And I did combine them with the two photo gates here. So laser gets covered and then it's blocked, and that's how the timer measures the time. Okay, that's all for now. See you.